Let f be a function with domain D. Then f has an absolute maximum value on D at a point C if f of x is less than or equal to f of c for all x in D, and an absolute minimum value on D at C if f of x is greater than or equal to f of c for all x in D. This lesson, maximum and minimum values are also referred to as extreme values. It is important to define our domain D when we refer to functions. Here's why. In the function rule, y equals x squared, the absolute minimum and maximum values vary depending on the defined domain. If we look at the natural domain of the function, negative infinity to infinity, there will be no absolute maximum, and the absolute minimum of 0 at x equals 0. If the domain is reduced to the inclusive domain of 0 to 2, there will be an absolute maximum of 4 at x equals 2, and an absolute minimum of 0 at x equals 0. However, even a single point of discontinuity can keep a function from having either a maximum or minimum value on a closed interval. If we look at the same function y equals x squared, but with a domain of non-inclusive 0 to inclusive 2, the absolute maximum remains 4 at x equals 2. However, there is no absolute minimum, since the minimum of 0 is not included in the set. Similarly, if the domain was non-inclusive on both ends of this domain, there will be no absolute extreme at all, since they are not included in the domain. This example leads us to our first theorem.